vanaja, assistant professor in Siddhartha Institute of Technology, Puttur. Today I am going to give video lecture on 8086 architecture and its feature. Before seeing the architecture, first we need to see what are the features of 8086 processor. Basically, it is a 16-bit microprocessor and it has 16-bit data bus and 20-bit address bus, which can access up to 2 power 20 memory locations, nearly 1 MB of address access. It provides 14 and 16-bit registers. It has multiplexed address data bus, which is from AD0 to AD15 and A16 to A19. 8086 is designed to operate in two modes, namely minimum and maximum mode. It can prefetches up to 6 instruction bytes from the memory, and those bytes or queues them in order to speed up the instruction execution. It requires plus 5 volts power supply, and the operating frequency of 8086 microprocessor is 5 megahertz. It is a 40-pin dual-in line package, and its address ranges from 000H to FFFFH. Now we have to, these are the features of 8086 processor. Now we will see what is the actual block diagram. That means internal architecture of 8086 processor. So if you see this internal architecture of 8086 processor, it mainly consists of two blocks. One is bus interface unit and another one is execution unit. In bus interface unit, internally it consists of 4 blocks again. So first one is address summer and segment registers, and third one instruction pointer, and finally instruction queue. While coming to execution unit, mainly it consists of control unit, arithmetic and logical unit, 8 general purpose register, and finally flags. Now we will see one by one function of the blocks inside this 8086 architecture. First we need to see bus interface unit. So in this bus interface unit, it handles all the transactions of data and addresses on the bus for execution unit. The bus interface unit performs all the operations such as instruction fetching, reading, and writing operands from memory and IO ports, and also calculating the addresses from the memory operands. The instruction bytes are transferred to the instruction queue. While coming to the execution unit, it executes the instruction from the instruction system byte queue. Both units operate asynchronously to give an 8086 an overlapping instructions fetched with execution mechanisms, which is called as pipelining. This results in efficient use of system bus and system performance. This bus interface unit contains instruction queue, segment register, instruction pointer, and address header, while the execution unit contains control circuit, instruction decoder, ALU, pointer and index registers, and flag register. Now we will see one by one. So this is the actual basic block diagram of bus interface, which already we see in the internal architecture of 8086 processor. So it contains mainly 4 blocks, which are nothing but 6-byte instruction queue, segment registers, instruction pointer, and address number. Now we will see what is the use of instruction queue. So this queue is used in 8086 in order to perform the pipelining operation. So bus instruction unit and the execution unit both used to execute the instruction from the memory. The size of this queue is 6 bytes. This means at the maximum of 6-byte instructions can be stored in this queue. The queue exhibits before operation. That means first in, first out. And we have to see what is the memory segmentation. As we already see the feature of 8086, the address is started from 00000 to FFFFH. Like this, the complete physical memory available in 8086 is going to be segmented by using these four segmented registers, namely core, segment, data segment, extra segment, and stack segment. The size of each segment is 64 kilobytes, and these may be located anywhere in the memory. And 16-bit contents of the segment registers in a bus interface unit usually point to the starting location of a particular segment. Now we will see what is the actual functioning of these segment registers. These are all 16-bit registers, as we already see in the previous clip. Each of these segment registers store the upper 16-bit address of the starting address of the corresponding segments. And we will see the each and individual segment registers functionality. While coming to the core segment register, it is a 16-bit register and holds the address of the instruction or program stored in the core segment of the memory. And stack segment register provides the starting address of stack segment in the memory, like in stack pointer, operations like push and pop, which is used in the segment to give and take the data to or from it. And data segment register. It holds the address of the data segment. The data segment stores the data in the memory whose address is present in the 16-bit register. Finally, extra segment register. Here, the starting address of the extra segment is present. This register is basically consists of address of the string instructions. So, these are all the blocks inside bus interface unit. Now, we will see another final block, which is nothing but the instruction pointer. So, instruction pointer is nothing but which is going to address the instruction to be executed next. This instruction pointer always refers the core segment register. The value of this instruction pointer is incremented after executing every instruction. And the summing block address summer usage is to form a 20-bit address of the next instruction. The 16-bit address of the IP is added to the address contained in the code segment, which has to be shifted 4 bits to the left. So these are all the blocks inside your basic bus interface. Nothing but segment registers, instruction queue, instruction pointer, and finally address. Now we have to see what are the blocks inside the execution unit. While coming to the execution unit, the basic functionality of execution unit, it decodes the instruction which are fetched by your bus interface unit, and it generates the control signals. After that, it will execute the instruction which are fetched by your bus interface unit. This is the block diagram of your bus interface. This is the block diagram for your execution unit. So, which is consist of 8 general purpose registers, control unit, ALU, operands, and finally flags. We will see one by one. First, general purpose register. So 8086 has 8 general purpose registers, namely AX, BX, CX, TX, and 2 pointer registers, that pointer, base pointer, and 2 index registers, source and destination index registers. This AX and BX, CX, DX are namely accumulator, base, count, and data registers, which is of 16-bit word length. So generally we call the 16-bit data as word. So this AX is used to multiply and divide on for IO operations in the form of word data. But the AL and AH represents 8-byte data. That means AL is lower byte data and AH is higher byte data, which is from your AX register. So it is going to do the byte multiplication, division, decimal arithmetics like that. And coming to the BX, that means base register, which stores the address information. And CX, which is going to use it for string operations and loops. And CL, variable shift and rotate operations. Finally, data registers is used for the word multiplication, division, and indirect IO operations. These are all the uses of your general purpose registers. And coming to the pointer and index registers, which is used to keep the offset addresses used in various form of addressing, memory addressing. In index registers, basically stack, source, and the destination index registers. This stack pointer used with the SS to access the stack segment, and base pointer primarily used to access the data on the stack, which can be used to access data in other segments. Coming to the source index registers and destination index registers, this SI is required for string operations. So it is associated with the data segment in the string operations. Coming to the destination index, also required for some string operations. This DA is associated with the extra segment in the string operations. Both SI and DA registers may also be used to access data stored in the arrays. Finally, the last block of your execution units is flag registers. In 8086, the execution contains 16-bit of flag register, which is going to store the status of ALU results. Out of 16, 9 are active flags, remaining 7 are undefined. Here in this flag register 16, it is a word length of 16-bit. In this, 7 are undefined. That means it is represented with U, and the remaining 9 are definable flags. In those 9, 6 flags indicates status flags, and remaining 3 flags are control flags. So namely carry flag, parity flag, auxiliary flag, zero flag, sign flag, trap flag, interrupt flag, direction and overflow flag. This is about the overall architecture and its internal blocks and their functionality of Intel 8086 microprocessor. Thank you all.